acid acts upon trousers. Taking everything into consideration, that was probably the most impressive experiment and relatively probably the most costly experiment I have ever performed. I tell of it even now with interest. It was a revelation to me. It resulted in a desire on my part to learn more about that remarkable kind of action. Plainly, the only way to learn about it was to see its results, to experiment, to work in a laboratory. So that's the reaction of nitric acid with copper, and it's produced these dark brown fumes, which you can see, and those fumes are called nitrogen dioxide, and they are actually pretty unpleasant, which is why we're doing this in a sealed apparatus. But nitrogen dioxide is a material that can help us understand this question about whether a chemical reaction can go backwards. So in these tubes, we have equal amounts of nitrogen dioxide. And what I'm going to do is to take one of the tubes and to place it in iced water so that it will cool down. And the other tube I'm going to place in hot water to heat it up. So we'll come back in a moment and see if they're changed in any way. So let's have a little look at the chemistry that's going on inside those tubes. Now, nitrogen dioxide has a molecule which consists of one atom of nitrogen and two atoms of oxygen. If we have two molecules of nitrogen dioxide, they can react together to form one molecule of another oxide of nitrogen called dinitrogen tetraoxide. Now, that process releases energy. When that extra nitrogen-nitrogen bond is formed, it gives out energy. So that's like the ball rolling downhill. The ball rolling downhill wants the nitrogen dioxide to come together and form dinitrogen tetraoxide. But the dinitrogen tetraoxide can split up. The molecule can split in half to give two molecules of nitrogen dioxide. And because for every molecule of dinitrogen tetroxide we get two molecules of nitrogen dioxide, we have twice as many molecules. They can be arranged in many more ways, and that means the entropy has increased. So the entropy tends to drive this reaction from the right to the left. So these two effects, the ball rolling downhill effect and the teenager bedroom effect, are driving this reaction in sort of opposite directions. What happens is that the reaction actually goes in both directions at the same time, and it reaches a sort of balance. We call it an equilibrium, where there is some nitrogen dioxide present and some dinitrogen tetroxide present. And the relative proportions of these depends upon the temperature. So if we increase the temperature, we put energy into the system. That's like pushing the ball uphill, and we go from right to left. And if we cool the system down, then conversely we go from left to right. So that's the prediction. And we can test the prediction because nitrogen dioxide is this dark brown gas that you see in the flask here, but dinitrogen tetraoxide is colourless. So if we go back to our tubes, this is the tube that was in the cold water, and you can see that it's become a paler colour, and this is the tube that was in the hot water. So I just put these side by side. You can see that heating up this gas has made it darker brown, contains more nitrogen dioxide, whereas cooling it down has made it less dark, it contains more dinitrogen tetraoxide. And just to check our theory, what we can do is we can take the hot tube, the dark tube, and place it into the cold water. And then the cold tube, which is the paler colour, we can place that into hot water. And we'll come back and have a look at those in a moment, and we'll see if they've swapped places. Okay, so that really brings us towards the end of the lecture. What I want to do is just to show you one more curiosity, and it concerns a rather interesting and unusual element. Now, this element was discovered in a mine outside a little town called Ytterby, which is near Stockholm in Sweden. And they had been extracting minerals from the mine, and they found a mineral that seemed rather peculiar. They couldn't understand what it contained until they realised that it contained a new element. This was sort of the beginning of the 18th century. Now, in those days, if you discovered a new element, you got to choose its name. And they decided to name the element after the town of Ytterby. So this element is called yttrium. What's rather interesting is that this mineral contained not just one new element, but they